Okay, so good day to our grade 8 Math Science students. So we're still on the fourth quarter. Okay, so we're still on our lessons for the fourth quarter. But this time we're on a new lesson. Okay, so this is going to be our lesson on chords, secants, and tangents of circles. This is going to be the first of those videos. Okay, so let's try to solve this super challenging problem. In the diagram below, the circles touch each other at point P. X, Y, and PQ are common tangents to both circles. Now, for this problem, they're asking us to solve for the measurement of angle PQX. So it will be this angle. Now, what's the measurement of this angle? Using what we know, the theorems that we know about tangents of circles. Okay, so for this problem, we can see two tangent lines. So we have X, Y, and then QP, and they are common tangents to both circles. Okay, so that means what theorems can we use about tangents that would help solve this problem? First, we can create a center for both circles. For the small circle, it's going to be point M, and for the big circle, it's going to be point N. Now we have a clue to solve this problem. The ratio of the two circles is 1:3, meaning the radius of the first circle, or of the smaller circle, circle M, is 1, and the radius of the big circle, circle N, is 3. Okay, so it's 3 times larger as the small circle. Okay, or 3 units larger. Okay, so let's try to connect. Okay, let's try to make M, P, and N collinear to each other. And let's connect YN, creating a radius of the circle, XM, creating the radius of the small circle, MP, another radius of the small circle, and PN. So that's the radius of, again, the large circle. Okay, so what we're trying to find is the measurement of angle PQX or XQP. Okay, so how will we solve for that? Okay, so we can draw a line that connects QM and QN to help us solve this problem. And we know in circles, when we have tangent lines and they intersect with one point on the circumference of the circle, we create right triangles. So therefore we can say that QYN, angle QYN is a right triangle. Angle QPN, okay, so that's a right triangle. Angle QPM is also a right triangle, and angle QXM. Okay, QXM. So all of them are they all measure 90 degrees. Okay, so if they measure 90 degrees, okay, QPM, QXM, okay, we also have QPN and QYN. There you go. So this letter N. So they all measure 90 degrees. Now to solve for this problem, we can denote a value, let's say A. Okay, let's say that this is small letter A. Now if this is small letter A, and we know that this is the radius of the circle, so therefore if this is side A, and we know that both of these angles, this a 90 degrees, and this also a 90 degree angle. So if this letter A, this should also be letter A. Okay, so therefore we have A and then A here. And if we have two A's here, so therefore the measurement of angle XQM, since we already have a 90 here, so that's gonna be 90 minus A. Okay, because 90 plus 90 plus so that's So that's A plus 90 minus A plus 90, so that should give us 180 for triangle XQM. Okay, so again, so that's 90 plus 90 minus A plus A, so that should give us 180 degrees. So these cancel out. So that's again for triangle QXM. Also the same for triangle MPQ. Okay, Okay, now, so since we know that the measurement of xqm is equal to 90 minus a, so this 90 minus a, and this also 90 minus a. So therefore, the measurement of this angle, of angle PQN, okay, so the measurement of angle PQN, okay, so that's gonna give us, since this is a straight line, so we have 180 degrees. Since we have xy is a straight line, minus 2 times 90 minus a, since we have 2 minus 90 minus a here, all over 2. Okay, since we have two congruent angles here, we have PQN and YQN as our congruent angles. So this is gonna give us 180 minus 180 minus 2a all over 2. I'm sorry, plus 2a. Plus 2a, because negative times negative is positive. So these cancel out. So this is going to give us 2a all over 2. So therefore, what's the measurement of this angle over here? The measurement of angle PQN is just a, and the measurement of angle YQN is just a. And since we have right triangles, so we know in right triangles, okay, dear students, our right triangles could be similar to each other. Yeah, they are similar triangles. Therefore, if we try to look closely here, we have triangle MPQ. On triangle MPQ, we can say that it's similar to triangle. If you try to look closely, since, okay, I'm going to use a different color so that you guys can see. Since this is letter A on angle M, and this also letter A and angle PQN. Therefore, if we try to draw it like this, so this is going to give us QPM. There's a 90-degree angle and there's A. So how would you rotate this triangle? So this is going to give us a bigger triangle. So this will give us P and Q, where and QP is also A. Okay, there you go. Okay, so for this problem, we can create a proportion, or we can create a ratio, since a proportion, since we know already that we have similar triangles. And what proportion can we create in order to solve for the value of QP, since both triangles share the side QP? So to solve for QP, we have QP here. QP all over, since we know that the value of, okay, since we know the value of this side here of MP is equal to 1 based from the ratio of the circle, and since we know that the value of NP here, so that's 3, since this is going to be the radius of our circle. So this is going to be QP all over 1 is equal to 3 all over QP. Okay, this is going to be our ratio. And to solve for the value of QP, so we just cross multiply. So that's QP squared is equal to 3. And if we take the square root of both sides, we're going to find the value of QP of this line segment over here. So let's try to draw that on red. There you go, so that we can see it. So therefore, the value of this side is just square root of 3. So therefore, QP, if you take the square root of both sides, QP is just the square root of 3. Okay, so let's try to draw our triangle again. So this is the square root of 3. Okay, and this is also the square root of 3. So if that's the square root of 3, okay, and we already have a 90-degree angle here. If you recall, guys, the 30, 60, 90 triangle, the special right triangles that we have, try to recall the pattern. So what is the pattern for the 30, 60, 90 triangle? Okay, so for 30, we have x, the smallest side, 60, so that would be x squared of 3, and 90, so that's going to give us 2x. Now, since we already found the value of the square root of 3, and that's the value of our given side QP. So therefore, QP must have the value of the square root of 3. MP would have the value of 1, and 2x would be our value for MQ. So therefore, we've just proven that we have a right triangle here. Now, if this is a right triangle, and this is the smallest side, okay, so that's MP. So opposite to that one should be 30 degrees. So therefore, what's the measurement of this angle? I'm gonna color it in blue, in dark blue, so you guys can see it. So this is gonna be, or it should be, 30 degrees. Now, if this is 30 and this angle is just congruent to this angle, so therefore this should also be 30. And 30 plus 30, so that should give us the entire, or the total angle measurement of PQX. So therefore the measurement of angle PQX, so that's just 60 degrees. Or 30 times 2, so that should give us 60 degrees. And just by using the ratio of the radius of these two circles, or the sides of these two circles, we were able to find specific angle measurements. It was a bit of a difficult problem, but we were able to solve it. And that's how we solve this problem. The measurement of angle PQX is 60 degrees.